Okay, this might look tricky, and it is not really. I mean, maybe a little bit, but if you just understand the trick here, it's not that hard. The trick is to just look at the slow step. That is what's called the rate limiting step. So part of this trick is to understand that if we can figure out the rate of the rate limiting step, that is the rate of the reaction. We know the rate law equation takes this form. Rate is the rate constant times the concentration of reactants to a specific power that we call the order. And here we can look at the stoichiometric coefficient in front of A, which is implied to be 1, and that's the power. And we know that because we're given the mechanism of this reaction. Usually we don't know the mechanism and we can't assume that the power is the stoichiometric coefficient, but here we can, because each of these steps is concerted. So assuming this is a balanced equation up here, then the stoichiometric coefficient of A is implied to be 1. The 1 goes here. And we don't really need to write 1 as a power, so our rate just ends up being this. But just to clarify, if for instance the balanced equation had a 2 in front of A, like 2 molecules of A are required, then the power here would end up being 2, and it would be second order.